Ever feel like your brain is just lagging behind, like it can't keep up with all the information out there?
It's a common feeling in our hyper-connected world.
Well, imagine if you could process information a billion times faster.
A billion times. That's almost inconceivable.
That's what we're diving into today on The Deep Dive. Get ready for some serious mind-bending science because we're talking about laser neurons.
Laser neurons. Now, that's something you don't hear every day.
And the really crazy thing is, this isn't just some sci-fi fantasy. Scientists have actually built these things.
They're real, and they're actually working.
That's right. Our source for this deep dive is a paper from Optica. It's called A Billion Times Faster: Laser Neurons Ignite the Future of AI.
Okay, now I'm really intrigued. What exactly are laser neurons, and how do they even work?
Well, to put it simply, they're artificial neurons made with lasers that can process information at speeds that make our brains look like snails.
So they mimic the way our brains work, but at warp speed.
Exactly. And the key here is that they're modeled after a specific type of neuron in our brains called a graded neuron.
Graded neuron, as opposed to.
The more common type is called a spiking neuron. Think of it like a light switch, either on or off.
Okay, I get that. Simple on-off signals.
Right. But graded neurons are more like a dimmer switch. The signal can vary in strength, creating a more complex and nuanced response.
So it's not just about firing or not firing. It's about the intensity of the signal as well.
Precisely. And that's what allows these laser neurons to process information so quickly and efficiently.
The paper mentioned something about 10G baud. What does that even mean?
10G baud. Yeah, it sounds like something out of Star Trek. Basically, it means these neurons can analyze 100 million heartbeats in a single second.
100 million. Hold on, let me process that for a minute.
Or, if you prefer, 34.7 million handwritten images per second. It's mind-boggling speed.
Okay, that's a lot faster than my brain can handle. So we've got the speed down, but what about efficiency? Lasers don't exactly scream energy saving, do they?
Surprisingly, they're actually much more efficient than traditional computers.
How so?
Traditional computers use electrical signals, which generate a lot of heat and waste energy. But these laser neurons use light, which is far more efficient.
It's like comparing a gas-guzzling truck to a sleek electric car.
Exactly. So we've got speed, we've got efficiency. What else makes this technology so groundbreaking?
Well, one of the key applications the researchers have been exploring is something called reservoir computing.
Reservoir computing? I'm not familiar with that term.
It's basically a way of using these laser neurons to analyze complex, time-based data. Things like stock prices, weather patterns, even music.
Data that changes over time, so things that traditional computers often have trouble with.
Exactly. But these laser neurons can handle it with ease, thanks to their speed and their ability to process those nuanced signals.
Imagine a weather app that could analyze real-time data and give you hyper-accurate predictions.
Or a financial algorithm that could predict market trends with pinpoint accuracy. The possibilities are pretty amazing.
It sounds like this technology could revolutionize a lot of different fields.
Oh, absolutely. We're talking about potential breakthroughs in medicine, transportation, finance, you name it. But I think one of the most fascinating aspects of this research is the discovery that a single laser neuron can actually act like a mini neural network.
Wait, so one tiny laser neuron can do the work of a whole network of neurons? How is that even possible?
It all comes down to how they process information. Even in isolation, these laser neurons exhibit complex behavior and dynamics, almost as if they're thinking on their own.
So each one is like a little brain in itself. That's incredible.
It really is. And that's what makes this technology so different. We're not just talking about faster computers, we're talking about a new kind of intelligence altogether.
Okay, now my mind is officially blown. We've covered a lot of ground here, but I think we need to pause for a moment and let all of this sink in.
You're right. We've only scratched the surface of what this technology could mean for the future. And that's what we'll be exploring in part 2 of our deep dive.
Stay tuned, because things are about to get even more interesting. We'll be right back after a short break. Welcome back to the deep dive. Before the break, we were talking about how a single laser neuron can act like a mini neural network. It's mind-boggling to think about what happens when we start connecting thousands or even millions of these things together.
It really is. And the potential applications are just incredible.
It is exciting stuff, but is this all still theoretical, or are researchers actually building these larger networks?
Well, it's still early days, but they are making progress.
Yeah.
The paper actually outlines some of the early successes they've had.
So it's not just a pie-in-the-sky idea. They're making it happen. What are some of the challenges they're running into?
One of the biggest challenges is figuring out how to connect these neurons in a way that allows for complex interactions and information flow. It's not as simple as just wiring them together.
Yeah, I can imagine. So what could we actually do with these larger networks? Paint me a picture of what a future with laser neuron AI might look like.
Well, for example, imagine a world where AI can analyze massive amounts of data in real time. We could make decisions and predictions with incredible accuracy.
Like what? Give me a concrete example.
Think about the implications for medicine. AI could help doctors diagnose diseases much earlier and more accurately.
Wow, we're talking about AI that could potentially save lives.
Exactly. Or think about self-driving cars that can react to changing road conditions in a fraction of a second.
Safer roads, fewer accidents. What about other fields? What else could this revolutionize?
How about education? AI-powered tutors that adapt to each student's learning style. We could provide truly personalized lessons and feedback, unlocking potential in ways we never thought possible.
Okay, so we're talking about a future with better healthcare, safer transportation, and personalized education. Sounds pretty amazing, but what about the potential downsides?
That's a really important question. Any new technology comes with risks, and AI is no exception. We have to think carefully about the ethical implications.
Especially if we're talking about creating AI that could potentially be more intelligent than us.
Right. And the researchers are very aware of that. They're committed to developing this technology responsibly and ethically.
That's good to hear. But it's also a reminder that this technology is incredibly powerful.
It is. It has the potential to change the world as we know it, and it's crucial that we have these conversations now before it's too late.
So you're saying that it's not just up to the scientists and engineers to figure this out?
Exactly. This is something that will affect all of us, and we all have a role to play in shaping the future of AI.
Well said. So what are the next steps for the researchers? What's on the horizon for this field?
They're focused on improving the speed and efficiency of these laser neurons even further. They're also looking at new ways to connect the neurons together to create more complex networks.
So they're not resting on their laurels, they're pushing the boundaries of what's possible.
Exactly. We're on the cusp of a new era of computing and artificial intelligence, and it's incredibly exciting to be a part of it.
It is exciting, and maybe even a little bit daunting. But before we get ahead of ourselves, let's bring it back to the research itself.
Right. We need to understand the science behind it all.
And that's what we'll be diving into in the final part of our deep dive. Welcome back to the deep dive. We've spent this episode trying to wrap our heads around this incredible new technology, laser neurons.
It's really remarkable stuff, and I think it's important to remember that this is about more than just building faster computers.
Right. It really feels like we're talking about a completely different way of thinking about intelligence.
Exactly. And we've talked about the speed, the efficiency, even some of the potential applications.
But I keep coming back to that idea of a single laser neuron acting like a mini neural network all by itself.
It is pretty amazing, isn't it? Even without being connected to other neurons, these things can exhibit some really complex behavior.
So each one is kind of like a tiny brain.
That's a good way to think about it.
Yeah.
Each laser neuron can process information in a way that mimics an entire network of traditional neurons.
And that's what makes this technology so different from anything we've seen before, right?
Exactly. We're not just talking about bits and bytes here. This is a system that could exhibit a completely new kind of intelligence.
It's a bit mind-blowing, to be honest, and a little scary, too. What happens when we start connecting thousands or even millions of these laser neurons together?
That's the big question, isn't it? It's something researchers are still trying to figure out.
It sounds like we're venturing into uncharted territory.
We are. We're exploring the very nature of intelligence itself, and it's incredibly exciting.
It is, and our listeners probably thinking right now, okay, but how is this going to affect me?
Well, this technology has the potential to change every aspect of our lives.
And that's why it's so important to have these conversations now, right?
Exactly. We need to think about the kind of future we want to create with this technology and make sure we're developing it responsibly.
Well said. So as we wrap up this deep dive, what's the one big takeaway you want to leave our listener with?
I'd say this is just the beginning. This research is still in its early stages, but it's showing incredible promise. Keep an eye on this technology because it really could change the world.
Couldn't agree more. And for our listener, if you want to learn more about laser neurons, we highly recommend checking out the full article in Optica. It's fascinating stuff. Well, that brings us to the end of another deep dive.
It's been a pleasure exploring this with you.
Likewise. And for our listener, thanks for joining us. We'll be back soon with another deep dive into the cutting edge of science and technology. Until then, stay curious.